Hello all, let's start section 4.2. Section 4.2 is logarithmic functions. Let's discuss first what is a logarithmic function. Then slowly I give you all 7 rules of logarithms and we start solving logarithmic functions, correct? Or deal with logarithms. If you remember from the chapter that we discussed functions, I also discussed with you the inverse of a function. If I have a function, for example, y equal b to the power of x, which we call it an exponential function, or f of x equal b to the power of x. Let me even put f of x for you, correct? If I write here f of x equals b to the power of x, I'll call this function a exponential function. Now, if I ask you to find the inverse of this function, if you remember, we had 4 easy steps to find the inverse of any function. I can find the inverse of an exponential function because exponential function is a one-to-one function, correct? If I do that 4 step here for you, first I'll change f of x to what? F of x to y. I will write y equal b to the power of what? X. The next step, if you remember, we interchange x with y. Then I can write x equals b to the power of y. And the last step was to solve for y. If you look here, y, it's not easy to solve this function, which is x, this equation, which is x equal b to the power of y. Solving for y is not easy. What we do here, we introduce a new type of function which represents the inverse of a exponential function, and we call those functions logarithmic functions. Correct? It means, in a very simple language, a logarithmic function is the inverse of an exponential function. The notation for a logarithmic function is y equal log logarithm, or we call it log x base b, because your exponential function was y equal b to the power of what? B to the power of x. This function y equal log x base b is the inverse of a logarithmic exponential function y equal b to the power of x. Now, if someone gives you a function, an exponential function, for example, y equal b to the power of x, and they ask you to rewrite this function in logarithmic form, how or which way you can rewrite this exponential function as a logarithmic function. What you do, there are different methods. In your book, they used a circle method, but I'll explain here in a different way for you. To write an exponential function as a logarithm, always put the symbol of logarithm, which is log, correct? Then let me put this one in a different way for you to make it easier for you. B to the power of x equal y, same thing, right? Then bring down this b all the way here. Then cross, y comes here, correct? And cut, x goes on this side. I think I rewrite the exponential function in a wrong way. Let me adjust it with your book, the same notation. Do not make you confused. If you have given as a b to the power of y, equal x, and they are asking you to rewrite this one as a logarithmic functions, put the symbol of log, bring down b here as a base, cross x comes here, then your equal sign, and cat y goes here. It means your logarithmic notation will be log x base b equal y. Numeric example. For example, let's say 5 square equal x. And they are asking you to write this exponent notation as a logarithmic notation. What you do, put the symbol of log, bring down, the base comes down here as a base, cross, x comes here, equal sign, cat 2 on this side, correct? X equal 5 square in logarithmic notation, log x base 5 equals what? Equals 2. Or the other way, they can give you a logarithmic form and they ask you to write it in exponential notation, correct? For example, if I give you log 64 base b equal 3, and I ask you to write this one in exponential notation, then bring down, b comes down, cross 3 comes here, equals cat, 64 goes here. Bring down, cross cat or cross cat. That's the easy sentence that you remember, and you can change from one form to another form, correct? Now, let's start slowly with some rules of the logarithms, and after that we can start solving logarithmic equations or problems, correct? The first rule, I can name it basic logarithmic rules or properties. Rule number 1, log of b base b always equals 1, correct? The reason, because b to the power of 1 is always what? B. That's the reason behind. This is rule number 1. I'll do now an example in red here for you. If they give you to find log of 10 base 10, immediately write your answer as what? 1. Correct? Log of 8 base 8, the answer 1. Correct? Rule number 1. Rules are easy. As long as you remember the rules, solving problems of logarithm is really easy. Rule number 2. Log of 1 base b is always 0. Because you know, any number to the power of 0 is equal what? 1 in exponential form. Correct? For example, if they give you, for example, log of 1 base 5, your answer immediately what? 0. Because log of 1 base b is what? Always 0. Rule number 3. Log of b to the power of x base b. In this case, your answer is this number, whatever the exponent is, x. For example, log of, let's say, 3 to the power of 5 base 3. Immediately, my answer is what? 5. Correct? Log of 10 to the power of 2 base 10. The answer, 2. Rule number 4. B to the power of log x base b. Your answer is again x. For example, 2 to the power of log 5 base 2. My answer is 5. Correct? These are the basic logarithmic properties. 4 of them. The other one is the product and the quotient formulas, which I'll give you later. Correct? Now, let's practice at least few more problems dealing with this 4 rules that we just learned. Example number 1. Find the logarithm. Correct? Let's say, for example, log of 3 base 3. If they ask you to find log of base 3 base 3, which rule you should use? Your rule number 1 says, if I have log of b base b, my answer is always what? 1. Then log of 3 base 3 is always what? 1. Example number 2. Log of 1 base 10. When you are dealing with logarithmic problems, you have to remember the rules. If you remember the rules, your answer to finding the answer for most of them takes a second, correct? You see here I'm dealing with rule number 2. If I have log of 1 base b, then my answer is always what? Always 0. Then the answer for this problem is what? 0. Correct? Later, when I explain to you the product and quotient rule, on that time, we will use a kind of more complicated problems of logarithms, and we will solve it for you, correct? Now, graphing logarithmic functions, correct? I like to teach this one at the end of chapter that we are studying logarithms, but in your book they brought it actually in section 4.2. Anyway, it's not difficult. Let's talk about this topic right now. Graph of logarithmic functions. If someone gives you to graph a logarithmic function, then what you can do to graph a logarithmic function. For example, if I ask you to graph a function g of x equals log of, let's say, x base 3. If I ask you to graph this function, then how you graph a logarithmic function? At the beginning of this section, I told you that any logarithmic function is the inverse of an exponential function, correct? Then, to graph a logarithmic function, first, the easy way is to find the exponential function for this logarithmic function, then graph the exponential function, and after that, easily you can find the graph of logarithmic function. If I want to write the exponential function for this function, g of x equals log x base 3, I can change this one and my exponential notation, and if I change this one in my exponential notation, this one will be g of x equals 3 to the power of x, right? Based on bring down cross cut, the way that I just show it to you, correct? And now, if I want to graph g of x equal 3 to the power of x, I already know how to graph this exponential function, correct? I need a table, here x, here y, and I need at least few points to plug in to graph g of x equal 3 to the power of x, correct? Let's, for example, use 0, 1, 2, -1, and -2. When x is 2, g of x becomes 9. If x is 1, g of x becomes 3. 0, 1, -1, 1/3, -2, 1, 9. Correct? You already know how to graph an exponential function. Okay, now let's graph it. X, this is y. When x is 2, y is 9. X, for example, 2, let's mark here as a 9, y is 9. This point. When x is 1, y is 3. 1, 2, 3. This point. When x is 0, y is 1. This point. When x is -1, y is 1/3. And the other one is really close to and 1, 9 like this. And let's graph our function. Let's graph this exponential function. This is the graph of your exponential function, g of x equals 3 to the power of what? X. Now, remember, the day that we discussed the graph of a function and its inverse, I told you every time that you want to graph the inverse of a function, the domain becomes range and the range becomes the domain. It means your y becomes x and your x becomes y for your inverse function, correct? It means if I want to graph here, for example, in blue color, the inverse of this function, I will just flip x as a y and y as a x, correct? When x is 9, actually, y is what? Y is 2, which is somewhere this point. When x is 3, y is 1. x3, y1, somewhere here. When x is 1, y is 0. It means this point. When x is 1/3, which is somewhere here, y is -1. This point. And if you graph you will see this one will be the graph of inverse of g of x equal 3 to the power of x, which is the inverse will be the logarithmic function, correct? G of x equals log x base 3, correct? Because remember I told you that the inverse of a function is actually symmetric about the y equal x, correct? This is how easily you can graph the logarithmic function, but you have to first change your logarithmic function to exponential function. Then after that, you can graph easily the logarithmic function. In this section, they just talk about the graph of logarithmic function. This simple, correct? They don't want you actually to graph all logarithmic functions. They just talk a little bit about logarithmic functions and they stop here their graphing, correct? One thing more that I want to discuss here very clearly for you, there are two types of logarithmic functions. The first one, which the symbol is log, we call it logarithm or we call it a common logarithm, correct? The next type of logarithm, the symbol is ln, which we call it natural log or natural logarithm, correct? The base, when you write log, the base, this number b. For the common logarithm, the base is always 10. For the natural logarithm, your base is always number e. It means when you have log of a number, any number, for example, x base e, instead of writing log x base e, you can write ln of x. It means when your base is e, natural number e, we change the symbol to what? To ln. The rules are totally the same as the logarithmic rules when you are dealing with natural log, correct? For example, if I list it for you, you have log of 1 base b equals 0. Now, you can write ln of 1 is also equal to what? 0. Correct? Or you had log of b base b equal 1. Here, we can say ln of e is always equal what? 1. Because ln of e actually means log e base e. Right? When log e base e is what? 1. Number 3, for example, you had log of b to the power of x base b, correct? And your answer was x. Here, ln of e to the power of x is always what? X. Or the fourth rule that we have for logarithm, b to the power of log x base b, your answer was x. Here, e to the power of ln e, your answer, ln x, sorry, not ln e, ln x, your answer is always what? X. Rules are the same if you are dealing with natural log or when you are dealing with common log, the rules are the same. Correct? Your section 4.2 stops here, correct? Your section 4.2 stops here. I will stop the lecture here for 4.2, and in 4.3 we discuss more properties of logarithm, and we will deal with I'll do a lot of examples for you to show it how to deal with a logarithmic problem. I'll stop the lecture here and see you all in section 4.3.